Alright, so this is our last video for our topic number 3. In this video, we'll be working on with the software that we'll use for the structural analysis problem. So this software that we'll use is the RISA 2D educational version. Okay, so if you visit their website, then you can actually find the link for this um, for for the software. Then they also provide a link for the educational tutorial. So it's a document wherein there's two problems, one for trust problem and then another is for frame problems. So gives a step-by-step procedure and how to use the software. Okay, so although this is an educational version, which means that it is intended for, it says here, students and professors can utilize a special version of RISA 2D, which is aimed at teaching and understanding the basics of structural analysis. So all this seems to be a limited version as relative uh, to an expanded version that they have, which can offer probably more capabilities. But for us in this course or for classroom purposes, this is actually more than enough. So um, we will use this one in our homeworks and sample problems. Okay, so if you click this educational tutorial, then you'll be open up in another browser this tutorial for Visa Educational. So this is the this document is written by CM Yuang and KM Lee. So it says here that it's for the textbook Fundamentals of Structural Analysis. Of course, most likely this textbook was written by uh, probably by them, and this one says this program has been developed to make the definition, solution, and modification of two-dimensional problem data as fast and easy as possible. Okay, so that's what I like because this is really fast and easy as possible. Okay, so now we'll work on some problems, or I think first we'll open up the software and we'll get acquainted on the interface. Okay, so when you open up the RISA 2D Educational, then you'll have this drop down menu and then some icons here where you can click, which is some of them can actually be uh, accessed, I guess, on this drop down menu. Okay, so you also have this grid lines. So this is where we draw, or this is where we can um, where we will model the structure and um, draw the members and then the loads and then stuffs like that. Okay, and then try to solve, and once you solve, then we can see the let's say the shear, the moment, the deflections, reactions. Okay, so let's go one by one um, on the drop down menu bar. Okay, so we have this file. So the file is typical for every software that we have encountered, commonly encountered. So that's file, and what you can see, this new open close save as. That's very typical for the edit. It's also the same um, for the global. This is unique. So um, the global parameter is model title. So this one is actually, if you run through the document, this tutorial document, then it says here that um, Okay, so this is what I entered. Okay, so this example 11.2 from their textbook. Okay, so if you type uh, the designer and then the number of sections, so that's number two. You can also select, like, for example, more than two sections. So basically the number of sections that, for example, a trust member that's having an actual or internal actual loads, then it can show forth, um, although the internal actual loads is uniform all throughout the length, then you can actually, I mean, even just if you select two sections, that's gonna be fine. But for flexural members, like for example beams, then I think more. I mean, since shear embedding moment diagrams differs at each section along the length, then probably you might want to increase the number of sections. Okay, so for this problem, we'll work on the first problem, which is the truss problem. Okay, so this is it. Okay, so it says that we'll just use two sections. Okay, and then for the units, so for the units, we have these units for each physical quantities like lengths, areas, linear force, and the rest. But at the bottom of this window, you can see standard imperial and the standard metric. So if you click this, let's say standard metric, then all the units here will be just um, transformed to the metric units. Like for example, the force that's in kilonewton, and then the length meter, area millimeters. And if you click standard imperial, then the units will just shift to the imperials units. Okay, so the point here is, if our problem is in metric, then we'll use this, and if the problem is in imperial, then we'll use this, and just be consistent with the units. Okay, so for our problem, for our first problem, the truss problem, that's standard imperial. Okay, so the next one is the view. So the view, we can zoom in, we can zoom out, and okay, we can also turn on or turn off the grid, or turn on or turn off the axis. Okay, so this one, the XY, so we can turn on, turn off. Okay, the boundaries, because we don't have boundaries yet, so that's why uh, nothing happened. Okay, so for the insert, then we can insert, for example, joint boundaries members or joint loads, which you can also see similarly in, I, I think this window here. Okay, so that's the data entry. So for example, we'd like to input joint coordinates, and we'll just click that, and then input the data. So for the boundary conditions, if you click, of course we need joints. Um, okay, so for the members, uh, it will just open another window for the data entry. Okay, so spreadsheets, modify, you can also modify and spreadsheets, and then once everything is set up, then we can just solve. Okay, so if we click solve, then if our input is correct, then we can um, see uh, the shear values moment, shear moment in the actual values, as well as deflections and support reactions. Okay, so alternatively, there's also some tools here wherein if you click this, draw new members. So it's something like a graphical option wherein we can make, uh, let's say we can draw the structure in terms of graphical approach. So draw members or boundary conditions, that's the supports, then apply joint loads or distributed loads, and then apply point loads or moments to members. So we can, that's another options. Okay, so for now, if you open up, if we follow the tutorial document, then it says that the unit should be in uh, standard imperial. Okay, and so the next one that we'll do is the grid. Okay, so for the grid, we notice that we have this origin, which is x0 y0. So we can actually um, specify a grid that's I mean rectangular, that looks rectangular or non-uniform or square. So we can set up like that. So for example, we'll try, it means that, so the first one here, it says 30 at 1, so meaning 30 spaces at 1 foot, and then this one is 30 at 1 foot along the y directions. So for 30, I mean for the x-axis, we'll try, okay, so 20 at, or we'll just use, let's say 2 at 20, for example. So 2 at 1, sorry. Okay, so what you'll see is we have two spaces, uh, and then at 1 foot interval. Okay, so we can also write, for example, or we can add, for example, 5 at 3. Okay, so we'll see. So you'll see that you can also construct it that way. So that depends upon the problem. That's a good thing about this. Okay, so you can also do that along the y-axis. So now let's go back to the problem. So it says that we'll input 4 at 10, and then 6 at 5. Okay, and then that's it. Okay, so step number 6 is we'll have to input the data. So data entry is, okay, so if it's not open, then you can just click this D. Okay, so that's data entry, and then the other one, I think this is the results entry. Okay, so for the data entry, we'll first define our joint coordinates. So for the joints, so it says here no data available for this spreadsheet. So we'll click this, and then we will label the joints. Okay, so first we'll label the joint A, then that's in, just to take note, this is our reference point, that's 0 0 here. So our joint A is at this point, so that's 0 30. Oops. Okay, so again, we'll input the joints. So we have actually joint A, B, C, D, and E, so for the truss. Okay, so let's the label would be, let's say the joint A, what would be its location in this grid? So we have 0 30. Okay, so it's simply because our reference point is here. So z- the x is 0 and then the y is 30. So for our b, it says 2030, and you can actually, it's actually stated in the document, page 5, figure 7 of page 5. So the b is 20, then 30. Okay, then next, letter c, joint c is 4030. Okay, and then joint d is 2015. Okay, and then joint e is 00. Okay, so that's now the joint. So now let's, um, step 8 says the boundary conditions. We have to specify the boundary conditions. So that's just referring to the supports. So let's go to the data entry and then click these boundary conditions. So this window will be open and then no data available for this spreadsheet. So press any key. Okay, so just click. So it says that at joint A, what's the boundary conditions? So we have a roller support. Okay, so the roller support is actually, we say that the roller has one reactions, and it seems that in this configuration, referring to the figure 1, so the configuration is that um, it's along the x-axis. Okay, so we have this tables here, so the x, y, and then the rotation. Okay, so along the x, that's where our reaction is. So if there's a reaction, then we'll select fixed. Okay, so let's click this. Okay, if you click this one, set boundary codes, um, then it just select, say, the fixed to all these 3 cells. Okay, so let's just leave it like that. So let's click fix and then OK. Okay, so that's the roller because it has only one reaction. Okay, next is joint C. Okay, so for joint C, we have a roller support, but the roller is along the y direction. So we'll click, or we'll select this cell along the y column. So we'll select the fixed. If it's a fixed support, then you'll just have to select all these 3, select reactions to all these 3 choices here. Okay, so next is the joint E. Okay, so for joint E, we have a, if you check it here, we have a pin. So a pin reaction will have two reactions, okay, along the x and along the y. Okay, so select these 2 reactions. Okay, so now we've set it up. So now let's go to the members. Okay, so for the members, we can now for the members, we can input the data in this spreadsheet, or we can also use the, we'll try using this one, the graphical tools. Okay, so let's click this draw new members. Okay, so if you click that, it says here what's the area, or what's the moment of inertia, and what's the Young's modulus. And you'll also see there's an I end and then J end. So basically this member, I think this refers to the internal, something like internal release or something like that. Okay, so going back to page 1, we have it says that assume the area of each member is 1.2 inch. So we'll input 1.2 inch squared. Then the Young's modulus is 29 KSI. Okay, what else? The moment of inertia. Okay, I think it's not, or I can't see where the value for the moment of inertia. So let's just leave it like that for now. Okay, and for the I end, so basically this is the starting point. So when you draw a member, it's a line. So starting point is the I, and then the end point is the J. So what's the condition of that end point, or that end? Is it a fix or is it a pin? Okay, so the problem says that it's a pin ends. Okay, so the I is pin, the J is pin. Okay, so let's click. Okay, so member 1 is joint A B. Okay, so you click here and then click the point B. Okay, member 2 is member BC. So from B, that's the initial point, and then C. Okay, what else? We have member 3, CD. Okay, C, and then this one is the D. By the way, we can also here we can view the joints. We can click this. We can also view the member name. I mean the member labels. Okay, so let's continue. Let's draw member. The fourth member is member D E. So from point D to point E, and then the fifth member is B. No, I think it's AE. Okay, so AE. AE. Okay, and then the next is BD. Okay, so this is it, BD. And then the last is this one. Okay, so that is our members. By the way, what's the boundary conditions? Oh, sorry. Okay, so sorry, this one should be letter E, joint E. Sorry. Okay, so this is it. So this will be uh, the label or the symbol for the roller support. Okay, so that's along the X. The reaction is along the X. This one, the reaction is along the Y. It's a roller. And if it's a pin, then this is it. Okay, so you can also see the data if you click this one, the members. So in this data entry, you click the members, you'll see the joints, the area, inertia, release. You can also edit the data here. Okay, so what else? Now let's input the joint loads. So the joint loads, that's in step number 10 of page 7. So let's click this, joint loads. By the way, we have 3 loadings selections here. We have this one, the joint loads or moments to joints, meaning the loading is at the joints, whereas here there's an apply point loads or moments to members. So this one is along the joint, this one is along the members, and another one is a distributed loadings to the members. Okay, so it says here we have a loadings at point. Okay, so if you check it here, we have a loading 9 kips at point B. Okay, so let's input joint loads. So what's the direction? We have this uh, this is a load. Actually, you'll see loads or deflections for joints, so you can also specify deflections. Okay, so this is a load, that's the selection. Another one is this is an enforced displacement. So if it's a displacement, then you can select this, but if it's a load, then that's the load. Okay, so what's the direction? It's downward. So I mean it's along the y. So y along the vertical axis, and then what's the magnitude? We have, okay, so for positive, that's if we input positive 9 or 9, then that's the direction will be upward. But if it's negative, then that's downward. So we'll input negative 9. Okay, so apply. So if you see here, actually our point here is the something like the target symbol. So what joint? Okay, so we'll click this joint, and you'll see that we have a negative 9 kips here. Okay, so you can also edit that here if you'd like. Okay, so if everything is done and ready, then we can click for solve. So for the solve, then we already click this, the solve. Then it can actually show, uh, you can actually show the reactions. So the reactions are here. So we have like this. We have um, we'll have a support reactions along the x or along the y, and then if there's moments, then we can actually compute that. Then another thing, we can also turn on or turn off the internal loads. So here we have actual, so we can see the internal loads. um, what else? Internal loads, shear loads. There's no shear because this is a truss, so there's no moment as well. Um, okay, so that's I think that's it. Okay, so now we can also see the results. So for example, select what's the joint reactions, the member forces. Okay, we can click that one. So it can also provide the tabulated results. So we see here that we have section 1, section 2, because in this global parameters, we said there's that we need 2 sections. Okay, so 1, 2, then what's the actual, what's the shear, what's the moment. Okay, so for the joint reactions, it can also show, like for example, the joint A, what's the reactions at X, Y, and many more.